When we look at a slightly more geometric example, we can see this problem for each diagram. Write 3 statements comparing the areas of the shaded and unshaded regions. In one statement, use fraction ideas to express comparison, in the second, use percents, and the third, use ratios. So in the first statement, we can easily compare ideas with fractional ideas. Our first cube has 5 parts, and 2 of them are shaded. So that means if we refer to the shaded over the total, we can write a fractional ratio to be 2 out of 5. Or if we rate it as shaded to unshaded, we can set it up as 2 to 3. Same proportions with the second example, 1 to 9 or 1 to 8, depending on whether you're using the total or you're using the unshaded as your denominator. When we move into percents, percents can be written from the fraction form, so 2/5 can be put into percent form by making a denominator that's equal to 100. We get from 5 to 100 by multiplying by 20, so we need to multiply our numerator by 20. 2 times 20 is 40, and that's what brings you to 40%. You can do the same thing with the second figure, so 1/9 put into a denominator of 100. We can't move from 9 to 100 with a common factor, so we need to do long division. 9 goes into 1 how many times? That will be 0 times. And then we drop ourselves a decimal and give ourselves a 0. 9 times 0 is 0. Do the subtraction, bring down 0. 9 goes into 10 once. 1 times 9 is 9. Do the subtraction, bring down a second 0. 9 goes into 10 once. This will repeat, so our percent in this case is when we move our decimal 2 places to the right or to the hundredths place, and it's about 11%. The last set that they ask us to do is to use ratios to make a comparison. That's pretty easy. We just say 2 to 5 and 1 to 9. We just set up our ratio with a colon. So for the last problem, this is the pool table problem that we looked at last class. It was pretty interesting, but some people had some issues following it. So for example, if I have pockets A, B, C, and D on my pool table, what I want to know is I always start from A, and that I continue to bounce off at a 45-degree angle until I land in a pocket. You are also counting the strike, so where the ball starts, and also the last, the finish point where it lands in the pocket as well. The data that I'm looking to examine is the length of the pool table. So for this example, we'll use the length from line segment AD. We're going to need the width of the pool table, which is line segment AB. And we're going to want to know the number of hits when we look at how many times does the pool ball hit the sides of the table. And that's going to give us some data that we can work with and hopefully write an equation for this set. Set up our table there. So for the first pool table that we're working on, we start at pocket A, and we continue to move at a 45-degree angle until we sink the ball into a corner pocket. When we go to count the number of hits, we have 1, 2, 3, 4, and 5. So there were 5 hits. Line segment AD has a length of 6, and line segment AB has a length of 4. So that's our data collected for the first pool table. The second pool table, we start again at pocket A and travel at a 45-degree angle until we end in a corner pocket, and this one's going to take us a little longer. And remember, you're always turning in on the pool table. You're never going to exit the pool table. So there's our hit straight through there. When we count the number of hits, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 hits for a pool table with line segment AD being a length of 7 and line segment AB being a length of 5. So the last data table that we have goes from pocket A, and we're going to travel off until we sink into a corner pocket. The last time. And this one seems to be the most complicated so far. There we go. So the final number of hits for this one is 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19 hits on a pool table with side length 8 and with 9. This is the data that you should have collected in class, and that would have helped you to develop an equation for this particular problem. You may have needed to use more pool tables to explore. If you kept this problem, or if you want an extra copy of this problem, this will be a challenge problem for over winter break, and it will earn you some extra credit. It may even count as a quiz or test grade. So please let me know if you want an extra copy of that. Thanks, guys.